Hello viewers, I'm Kausalya. Today we are going to solve problem 13 in exercise 10.2. The problem is prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. So here you see we are having a quadrilateral circumscribing a circle, right? So this is your quadrilateral and this is the circle. And opposite sides of the quadrilateral, they make supplementary angles. So here, what are all the opposite sides of the quadrilateral? So you see, that is opposite angles, right? That is this angle and this angle. When you add these two angles, they should make an angle of 180 degrees. Similarly, the opposite angles are this spot and this spot. They have to make an angle of another 180 degree, right? This is the thing what we have to prove. So just write, you see, angle AOB, okay? AOB plus COD is equal to 180. Similarly, angle BOC and AOD, right? BOC plus AOD equal to 180 degree. So this is the thing what we need to prove, right? So in this case, we are just doing some constructions. Okay, we are drawing some extra lines to prove that. So, to prove that, you see, here we are establishing the point of contact. Right, we are giving a name to the point of contact. So, here they are P, Q, or S. Right. So, from the, we are connecting the lines from the center O to the point of contacts. Right. So, here we need to join OR, OS, OP and OQ. Right. So, this is the key thing to be done. Once it is done, then it will make our way of solving the problem easier. Right. So, here, you see, this is the construction. We have to join OP, OQ, OR and OS. Right. Now, we have to prove. So, in order to prove, again we are going to consider two triangles and finally we are going to prove that these two triangles are similar so that we can discuss with the angles, right? So, now consider the triangle OPB. You see, we are considering the triangles OPB and OBQ, right? So, we are taking these two triangles, right? This is one triangle and again this is your another triangle. We have to prove that these two triangles are similar. Once these triangles are similar, then we can write this angle 1 is equal to angle 2. Okay, mention the angles also. It will make easier. So, this is angle 1, 2, similarly 3, 4, 5, 6, 7, 8. So, here in this case, we are going to prove that angle 1 is equal to angle 2 and angle 3 is equal to angle 4 and angle 5 is equal to angle 6. Finally, angle 7 is equal to angle 8, right? So, in order to make that criteria, here we have to prove that this triangle is similar to this triangle, right? So, how we can prove that? Again, the same thing, okay? That is this triangle and this one. So again OB is common, right? OB is common to both these triangles. And the next thing is, you see, OP is a radius, right? Because it connects center to the circumference. Similarly, OQ is a radius because again it connects your center of the circle to the circumference. So here OP is equal to OQ. We can write, right? So OB is common. OP is equal to OQ. Then again, B is an external point. So, B is an external point, right? And BQ and BP are the tangents. So, how they will be? Again, BP is equal to BQ, right? So, now we had finally proved that, right? So, triangle OBP is similar to triangle OBQ because three sides of one triangle is equal to the three sides of some other triangle. So, by SSS congruence criteria, we have proved that angle 1 is equal to angle 2. right? Now you see we can prove angle 3 equal to angle 4. How we can prove? Again you have to consider this triangle and this triangle, right? You see this is an extra line, okay, don't consider. While drawing in sketch I got it as 2. So this is one line. So again you see OQ is equal to OR. Why? Because they are radius. And this side OC is common. And finally this CR will be equal to CQ because C is an external point and CQ and CR are the tangents drawn to the circle from this external point. So in this way we can prove that angle 3 is equal to angle 4. Right. Same way angle 5 equal to angle 6. Again the same thing holds good. You see OS is equal to OR. OD is common. And DS is equal to DR. Right, because D is an external point and DS and DR are tangents. Similarly, OA is common. OS is equal to OP. Right, and then this AS is equal to AP. Okay, again the same thing, same criteria. So you can prove that angle 1 equal to angle 2. Similarly, angle 3 is equal to angle 4. Angle 5 equal to angle 6 and angle 7 is equal to angle 8. Right. So finally you see we had proved that, okay, angles are equal in this way. So now I am going to add all the angles. Right. So when you add all the angles, how many angles do we have? We are having 8 angles in this diagram. Right. So this forms, that is just like a circle. Right. It starts from 1 and it ends at 8. You see it starts 1 and it ends at 8. Okay, this forms a circle, right? So the angle here is 360 degrees, right? And again angle 1 is equal to angle 2, right? So again you have to look at the diagram and you have to make sure which angle to modify, right? So here the opposite angles are AOB and COD. So in AOB, I am having angle 1 and 8. So we have to keep this 1 and 8 as such. And in this side, I am having 4 and 5. So I have to keep this 4 and 5 as such. Right. So you see here I have to keep 1, 8 and 4 and 5. So we can change the remaining angles. So 1 is equal to 2, right? So replace 2 with 1. And 3 is equal to 4, but I want 4. So replace 3 with 4. And again I need 5. So replace 6 with 5. And here I need only 8. So replace 7 with 8. Right. So again each angle is 2 times 1 plus 1. So 2 times of angle 1, 2 times of angle 4, 2 times of angle 5 and 2 times of angle 8. So take this 2 outside. So when you take these 2 outside, the angles are 1 plus 4 plus 5 plus 8. Right. So here, the next thing I am moving this 2 to the right hand side. So 360 by 2 gives 180 degrees. Right. So you see these terms are in addition. Right. So again when you look back at the diagram, so AOB, this is the angle I want. So I need angle 1 and 8 together and 4 and 5 together. So combine like this, right? 1 and 8 together and 4 and 5. So 1 plus 8 gives angle AOB and 4 plus 5 gives angle COD. So which is equal to 180. That is supplementary. This is what we need to prove. And again, we have to prove the remaining, that is other 2 opposite sides, right? What are all the other 2 opposite sides? So again from this diagram, BOC and AOD. Okay, these 2 are the opposite sides. So here we have to include the angles. We have to keep the angles 2 and 3, 6 and 7. So here I need 2. So modify 1 as 2 here. And I need 3. So change 4 as 3. I need 6. So change 5 as 6. And similarly I need 7. So change 8 as 7. Again when you add, everything will be 2 times. Right. So again when you combine, 2 plus 3 gives you the angle BOC and 6 plus 7 gives you the angle AOD, and again which is equal to 180 degrees. Right. So here comes the end of this exercise. If you have any doubt, Let me know in the comment section. Thank you.